The boron and the fluorine bond energy is found to be 646 kilojoules per mole, whereas CF bond energy is 515 kilojoules per mole. The correct reason for higher bond energy of boron and fluorine in BF3 as compared to that of CF bond energy in CCl4 in CF4. There are two molecules, one is CF4, second one is BF3. The boron and the fluorine bond energy in BF3 is found to be 646 kilojoules per mole, whereas the CF bond energy in CF4 is found to be 515 kilojoules per mole. This one is higher value compared to this one. The reason behind having higher bond energy for the boron and fluorine compared to carbon and fluorine is what? Suppose if I go for boron trifluoride, that is BF3, we will write the regular structure of boron trifluoride is like this. But boron is having an vacant orbital, fluorine is having lone pairs. One lone pair, second lone pair, third lone pair, like this. Lone pairs are present. This lone pair present on the fluorine on any one of them is donated towards the vacant orbital of the boron. As a result, there it happens partial bond. This is bond 1, bond 2, bond 3. We explains this bond in the form of what? A partial bond, that is one bond is repeated. So we wrote that one as 1/3 of bond present between the boron and the fluorines. So therefore it is not exactly one bond. It is considered as 1.33 bonds. Due to this particular reason, officially it appears as 3 bonds. But whereas there are 4 bonds, so therefore each particular bond averagely will becomes equal to 1.33 bonds. Due to this particular interactions existing between the p orbitals of fluorine and the vacant p orbitals of the boron, p pi interaction results more strength. Due to this extra added strength, the bond energy of the boron and fluorine is found to be higher per mole, that is 646 kilojoules per mole, which is higher than that of the CF bond energy, which is found to be 515 kilojoules per mole.